Hello all. In the figure, you see the MSP432 board and its associated pinout. So, if you see here, this is the MSP432 P401R, where P 6.5 and 6.4 pins, which are I2C SCL SDA, are being pulled out, and then the pinout of MSP432 is shown here. You can see here these are the two pins in the UCB interface. So those two pins are connected to an EEPROM, external EEPROM, because MSP432 board eval board doesn't have onboard EEPROM, so we have used an onboard EEPROM. And these two pins which are there are connecting to a EEPROM board which we purchased in the local market, which has 8024C16A device on it. So if this particular code you write works for a specific interface, it works for all the EEPROM devices. So you can use this sample code which we are going to show, which we are basically going to explain for your boards as well. So, and then this is the EEPROM as we were talking. For this particular board, for AC20 8024C16A, actually the write protect is just pulled out, and then this is connected to a GPIO. So that GPIO is actually P4.6 here. The green wire you can see here, the green wire gets connected to this WP, and then the power 3.3 and ground are also pulled from this MSP432 board. So as we got an idea of how the connections between MSP432 and the EEPROM board are connected, we will go and have a look at a simple code which we just try to take from one of the sources over internet, and we just modified it to show you how any EEPROM code works. So you can see the pull-ups. I2C needs pull-ups, we know, right? It's an open train interface, so the pull-ups are there on the EEPROM board. So the microcontroller board, even though it has these two come parallel, so we are not bothered about the length of the routing, capacitance, all these at this moment, right? So you can live with different pull-up resistance than the normal one as well. Now let us have a look at how the code is written for this. What you see here is the Code Composer Studio. So actually, the main important point while writing an EEPROM code is to know the slave address of the I2C. So if you see here, this is the datasheet of 8024C02. So the device address, actually, this is a 16K device. So the device address, so the first 4 bits are fixed, and then P2P10 for 24C16A device is 0, because P0, P1, P2 are grounded on the EEPROM board that we have seen. So that means when we go back, so these are 3 zeros, and then if you consider 1010, that means these are 4 zeros, which is 0 in hex, and 101, which is 5 in hex. That means the I2C address of this particular slave which we are using, the EEPROM I2C device, is 0x50. So what we did is we just try to take that device and then define a particular size of data which need to be shown, and then we declare two arrays. One is called test data and other called is read back. So test data is used to first send data, and read back is used to capture the data. And then what we are doing is we are also using the UART in parallel, and just try to send some information over UART such that it helps in debugging and also understand what is happening. So initially UART is initialization is done, and then we are just trying to print something. And then if you see here, this is basically the write protect pin configuration P4.6. So what we are doing is we are just trying to set the direction of P4.6 to output, and then we are outputting a 0 because write protect should be 0 to enable write and read operations on EEPROM. And then we are doing I2C initialization. If you just go here, we are just trying to select the pins here, that's it, and then do the configuration as per the requirement. Like we are selecting 7-bit address, the master mode, and using the SM clock for this particular device. So that's the setting you get out of this. So and what we are doing is basically we are using the 100 kilohertz I2C mode here. So that's what the setting is done in BRW. So very simple initialization. I2C initialization basically involves the I2C configurations, whether it is 7-bit or 10-bit address, whether it is master mode or slave mode, or what is the clock that need to be selected, and the pins. So these are the main initializations that are done here. And then to the test data, we have just put a byte, and then we are going to write using this function. So you can see here we are just trying to put the address, enable the transmitter, and then start bit, and then try to send the data, and then send stop bit. So that's what we are just doing here. And then we are just acknowledging the receiving the acknowledgement. So if you go here, you can see that we are just trying to wait until the next communication can be done. That means the acknowledgement is received. And then you can see here, once that is done, what we are doing is we are just trying to read from the same address. um, we have pushed data to 0 location in a EEPROM. A 1 byte is pushed actually, 0 location 1 byte, and this data 0 cross 1 0 is pushed. So here what we are doing is just trying to read, okay, and then we are comparing the read back and test data. That means whatever is read and whatever is pushed, to give the status out of this function. So if these both are equal, so we can just go to this function. So what we are doing is, you can see here we are just comparing the data that is read and that is pushed. You can see this is what comes into this function, okay, the test data and read data. If they are same, return 1 or 0. So one, based on the status, we are saying whether it is write is successful or write failed. This is how a simple I2C communication is done. So just try to take the basic functions that are available, and then try to integrate it into do an EEPROM. A very simple thing, we just tried with 1 byte, write a byte to EEPROM, read that byte, and compare to see if they are equal or not. You can just try to uh, do several things with this, and like example, you can save configuration data at different locations and then read based on the need, because EEPROM basically is used for saving the configuration data. Hope we could give some information on how to write to EEPROM. Please post if you have any questions. Please post your comments on the video. Please subscribe to our channel. Thank you.